Hello everyone. In this video, we'll be talking about Langchain. Langchain is a framework built for interacting with LLMs and finishing complex tasks using decision making by LLMs. It provides a lot of convenient abstractions and functionalities to build for complex use cases. And plus, it since given it's open source, it has a lot of functionalities and utilities, which makes it easier for developers like me to just build something complex with just a few lines of code. So when I say LLMs, I think at this point everyone knows what LLM is, but let me just give a couple of lines about it. Uh, LLMs are large language models. So think of it as a machine learning model trained on a huge amount of data and parameters, and it's able to take a user query and then somehow there's a lot of magic under the hood, but it's somehow able to respond back in a very coherent way, and most of the times a user will not be able to differentiate whether a human answered it or a machine. So it's very smart. So now we'll be talking about the major components in Langchain. So the first one is LLM/models itself. Okay, so before talking about it, I'll go over quickly on how to set up the environment. So given it's a Python project, the first thing which we should do is we should set up a virtual environment. So I have already set mine, and you can do it using this command. This particular thing creates a environment named vnme. Then we'll go ahead and install the dependencies. In this case, it's Langchain library, so framework, and OpenAI AI client. We can just install it using this play button itself. If you're executing from the virtual notebook, from the visual notebook, we must make sure that the kernel over here is selected to the Python in the virtual environment we just created. This ensures that our global Python is not affected by the packages we're installing over here and keeps things isolated. Next, we'll set up our environment variable called OpenAI API key. Now, this key is basically we can get it from openai.com, and this lets us call the models programmatically. So we'll be talking about the models. So LLMs in context of Langchain are an interface to talk to the real LLM models like OpenAI GPT, Google's Bard, any other models, open source models on Hugging Face. We can the best part about it is that it's the same interface to talk to models of different kind. I can host my own model itself running on my computer or in my AWS notebook, SageMaker, or Azure, or wherever, and I can use the same interface to talk to it. It's the most basic primitive, and think of it as a basic lowest execution unit in Langchain. And if you want to talk to a model, just send a query and just test things out. This is the fastest way to do it. Now there are two types of models, language model and chat model. So language model is the actual large language model. It takes a text as an input, does a lot of processing, and then finally returns an output to the user. Chat model, on the other hand, it's a variation on language models. While the chat models, they do use the language models internally, it's just that the mechanism, the interface with which we talk to them changes slightly. So rather than a text in text route API, we have to pass something called chat messages. So if you've ever played on playground.openai.com, we have to basically with chat models we have to specify something called system message, a human message, AI message. We won't get into details, but in a way both these models are interchangeable, and with some modifications we can use one model as another. There's no difference as such. So we'll go through this example first. Now what we're doing over here is we are importing the OpenAI module from Langchain, and then we are instantiating an instance of OpenAI. So OpenAI is nothing but just a LLM think of it as an LLM interface provided by Langchain. We are specifying which model. In my case, I'm using 3.5-turbo. It is the second best model out there, especially by OpenAI. The first is obviously GPT-4. To get API access for GPT-4, there's a waiting list currently, so I'm using 3.5, but 3.5 is good for almost majority of use cases. Then I'm setting something called temperature to 0.7. So temperature is on a scale of 0.0 to 1. Think of temperature as the the higher the temperature, the lesser the deterministic responses. So if I set my temperature to 0, then if I ask LLM a question, it will give me the most standard and the most boring answer. And if I keep on asking it the same question again and again, it will return me the same answer again and again. So this makes it sort of deterministic. If I set the temperature on the other hand to 0 to 1, then what happens is whenever I ask a question, LLM will return the most creative and most out of the box answer. Sometimes it's inaccurate also, but most of the times it just gives a very interesting answer. And on each time I ask a question to it, it will just return a different answer all the time. So that's temperature. I'm setting it to 0.7. This is a default which OpenAI also recommends for the model. So I'm going to ask for name of a company selling eco-friendly clothes. This is the prompt. Prompt is just the input, just the word for the input we give to the models, and then we execute it using this instance. Now, if I run this, I can see green threads. Now, since our temperature is on the slightly higher end, if I run this again, most probably I should get a different answer. Yep. So I got something called green threads go. If I set the temperature to 1 and play this, I can see it's called eco threads. Now, let's come to the second primitive or the component in Langchain. It's called prompt template. So if prompts are the inputs to LLM, think of prompt template as a structure which fixes a part of the prompt and only keeps a certain sections of the prompt as dynamic. So think of it as this way. In the above example, we ask the LLM to give a name for a company selling eco-friendly clothes. Now, what if I want to build a service which exposes a UI to the user, and the whole aim of the service is to generate names for a company? I don't want the user to enter the information, give me a name for a company selling. All I want the user to enter is the actual subject of the company, the product of the company, right? Because this makes it more convenient for the user as well as for me to manage. I have more control over the entire prompt. A user can enter anything, so it's better to use it this way. Now I'll go ahead and show a demo. So this is a template. This is a normal Python string. Now this, I'm creating a prompt template from this above string. Now, if I want to actually fill the value of this particular product over here, what I need to do is I just need to use something called dot format, and naming the variable, I'll pass the value. Okay. Now, we might think that what is the use case for creating something called prompt template? The same thing can be done using different substitution mechanisms in a string. For example, in Python, we can do something called f string. So if you see this example, what is a good name for a company that makes product? And if I try to print the prompt, it will. So let me comment this. Let me print the second one. So for the second one, I can see that what is a good name for a company that makes socks. And if I print for the first one, I can see the same thing. So now one may think, what's the point of creating a prompt template, different structure altogether? Well, there are a lot of benefits. One, prompts, while this may seem like a one line of prompt, Actually, prompts can be very complex, and using templates help in managing. We can string together different types of prompts together, and we can pass examples. We can do a lot of things using prompt templates. Plus, in LangChain, all the other components, they sort of depend on, they sort of expect prompts in the form of prompt template itself. Now, we'll be talking about the actual fun part called chains. So chains, till now, I've shown you prompt template and LLM. These two primitives are the sort of building blocks, but in a real application, we need to use multiple primitives to do something of actual value. So a chain is basically made up of links. Think of a real chain, and a chain is made up of multiple links. So in LangChain, each link can be a primitive like LLM or prompt template or other chains. So we can use chains to string together a set of operations. So there are different types of chains in LangChain. The most core type of is something called LLM chain. So we are importing the prompt template along with OpenAI LLM chain. We have created a template variable. This is just a string which takes product as the input. Now LLM equal to, we are creating an LLM instance. We are creating a prompt from the prompt template using the method called from template. Then we are finally creating the LLM chain. We are passing the prompt as well as the LLM. Now let me comment this, the below code. If I try to run this, I can see it says clacket rubber co. So this is basically substituting the value rubber hen in this template and then passing it to the LLM chain. Now, in a similar manner, we are not limited to just one variable. We can use multiple input variables in a particular template. Now here I'm creating a prompt by creating an instance of the prompt template directly. So if you notice this line and this line, there are subtle differences, but we can use either way for instantiating the template. In this mechanism, we need to specify that what are the input variables, adjective and subject. In this particular example, LangChain automatically deduces that, product is a substitution, so this would probably be the variable for the input. Now we create a chain and then we just go ahead and run. We are passing the value of the input variables. Adjective is sad and subject is ducks. Now if I basically run this code. So why did the duck cross the road? To get to the pond where he found out his family had been taken by hunters. So we can see this is a sad story. Sorry, what was the prompt? This is a sad joke about ducks. And now the problem with LangChain is since it's going under rapid development, there are similar methods. So there are duplicacy. There's a lot of duplicacy in the framework. So for example, I can use dot predict, dot apply, or just directly call LLM chain like this. I can pass the variables and its value, and all of them have basically the similar output. There are subtle differences. For example, in one of the mechanisms, I think in predict, we need to instead of passing it as a dictionary, we need to pass it in a separate way. There are slight differences in the expected output, but all in all, this we shouldn't get confused by it. These are just minor semantic differences, and either of the mechanisms will work. Now we'll be talking about sequential chain. So now we use LLM chain to perform an execution, right? Now we want to have separate LLM chains and we want to execute them one after another. So we want to pass the output of one chain to as an input to the another chain, and we want them to execute in a particular order. So here is where we use something called sequential chain. So I'll go ahead with an example. So we are doing the imports and creating the LLM model. So this is a first chain. This is basically for writing a synopsis given the title of the play and the era it is set in. So I can see that the prompt template is basically you are a playwright, given the title and the era, write a synopsis for the title. It takes title and era as an input. I have created prompt template and I have mentioned that this is the input variable, title and era. Now I create a chain, synopsis chain using this. And I also here, we don't need to specify output key when we are running LLM chain. It by default is named as output. But in sequential chain, it makes sense to name them according to your business logic. So in this case, I'm telling the LLM chain that, hey, whatever your output is, its name should be called synopsis. It should be in a variable called synopsis. Now I have another LLM chain which writes a review of a play given a synopsis. So you're a critic and your job is to write a review for the play. So this takes synopsis as an input. And in a similar manner, this creates review as an output. Now, finally, the third one, you are a social media manager. Let me just press enter. And your job is to write a social media post for the play. So this takes synopsis, review, as well as time and location as an input. So I create another LLM chain using this called social chain. Now, so we can see we have 3 different chains and each of them perform different tasks, but in a way they are dependent on the previous execution for their input variables. We can do this using f string also, but now we can see that it will become very complex to manage if we try to substitute the variables ourselves using the f string mechanism. So now we are creating something called sequential chain. So this takes the list of chains in the order in which we want them to execute as an input. So these are the chains we created above: synopsis, review, and social. The input variables are the combined variables for basically anything which the user has to enter. So in this case, it's the era, the title, the time, and location. The intermediate inputs, basically the outputs which are used as inputs to the subsequent chains, they are not to be mentioned over here, because Langchain automatically sort of stitches things together and it knows that I need to use the previous chain's output as the input to the next chain. And then finally, I'm mentioning what is the output variable, the name of the output variable after executing the entire chain. And verbose is something we will talk about it once we come to agents, but verbose basically prints a lot of logs and helps us understand what is actually happening. Now I'll execute the entire chain. I'm passing the variables and the title, era, time, and location. So I'll go ahead and hit play. Okay, so now we have the finished chain. It's telling me these 4 were the inputs I gave, and this social post text is a final output. Join us on December 25th at blah blah blah. A gripping play set in Victorian England, and the acting is superb, the tension between family members, etc., etc. So we can see that a social media post has been created finally using the synopsis as well as the title. Yep. So this is all about sequential chain. Whenever we want to perform a set of predetermined steps in an application, we can create chains for each of the steps and then stitch them together. Okay, now let's come to the most interesting part of a Langchain, which makes it super powerful: agents. So agents can be thought of as robots with LLMs powering their brains. So what is the difference between a chain and an agent? Chains are used for a predetermined set of executions. When we know during programming itself that what are the set of steps which will be executed, then we can create chains for each of those operations. But what if the input is dynamic? Let's say a user has the free ability to ask whatever they want. Okay, so in addition, there are a lot of advantages with agents has. Apart from being dynamic, they can use something called tools to supplement LLM's brain. So like a human being will use a calculator or for maths or perform a Google search for getting latest information, we can configure agents to use tools to perform similar operations. Tools are nothing but convenient functions which an agent executes for a particular operation. They use, again, agents are completely powered by LLM. So whatever decision an agent takes is powered by the LLM itself. The decision of which tool to use when, that is again powered by the LLM. I'll explain later how that works. So there are multiple types of agent. Again, what we'll be using is a zero-shot React description. The name sounds very complicated, but it effectively means that the agent has no memory. I ask a question to it, it will give me an answer. If I ask a follow-up question, it won't know the context of the first question itself. So, yep. Now I'll go through the example. So we have imported these methods which we'll be using below. So we are instantiating the LLM as usual. We are creating a tools array. Then we are we are basically instantiating an instance of the Google Search API wrapper class. Google Search API wrapper is basically a third-party Python library which is used for making API calls to Google Search. We also need to ensure that the library is also installed. This is a separate Python package. So the easiest way to do this is pip install Google API Python client. Now, once this is done, I also need to pass it API key and a custom search engine ID. So it's very easy to create an API key. We need to go to the developer console of Google and create it. There are a lot of guides online, and I think it's easy to figure out how to do this. Once this is done, so this is not a tool. This is just an instance. Now I am creating something called tool. For creating a tool, I need to name it. I need to give a description in text. And then I also need to give it the ingress point, basically the method which needs to be executed when this tool is triggered. So in this case, it's search.run. So the .run would be basically a method provided by the Google Search API wrapper. Then I'll append it to a list of tools. And I'll initialize my agent. Initialize agent is again a method, convenience method provided by Langchain. I'll mention the type of the agent. For now, we'll just stick to this. What are the tools I'm using? And what is the LLM which will be used as a brain for the agent? Verbose is again whether I want to see the thought process of the agent. And max iterations I'll come to a bit later. Then we'll finally execute which teams are in the Champions League final in 2023. Yep. So I can see the output is Manchester City and Inter Milan, which is actually true. So how does the model know who is in the final in 2023? The cutoff period of models training, at least for GPT, is I think sometime in 2021. So there's no way for it to know what happens in the future. So this is where the tool Google Search comes in handy. I'll explain a bit later as to how this actually works under the hood, but let's continue with the examples. But what is important is we can see Google Search and we made a search result, and LLM was able to figure out that Manchester City and Inter Milan are the finalists. Next, we'll use multiple tools. So there's again a method called load tools provided by LangChain. LangChain comes packaged with a lot of tools already defined by other developers like Google Search, LLM Math. So in the above example, while I had to create a new tool myself, I don't actually need to do it. LLM provides it. So sorry, LangChain provides it out of the box. So all I need to do is use a method called load tools, pass the list of tools I want to use. In this case, LLM Math, Google Search. Again, I'll be initializing my agent, and then I'll be finding the query. What is Leonardo DiCaprio's age? Raised it to the power 3.57. Okay, so I can see the execution succeeded. Let's go over the flow. So the first thing which my agent did was use Google search to find Leonardo DiCaprio's age. And on the basis of the Google search, it thought that that DiCaprio was born on 11th November 1974. So his age would be 48 years old. Then the next question was in the same prompt itself, raise it to the power 3.57. Now, LLMs are notoriously bad in doing maths, complex maths. So it knows that it needs to use a tool called calculator. So calculator is the name of LLM math. And it's passing the 48 as an input, and then this is the final answer. So now it's returning me the final answer. Leonardo DiCaprio's age raised to the power 3.57 is blah, blah, blah. If you check in a calculator, this is the correct answer. So we saw how an agent was able to figure out dynamically which tool to use for what particular query. So this makes agents very, very powerful. And the good thing about LangChain is it comes pre-built with a lot of useful tools for querying a SQL DB, for talking to AWS Lambda, for querying CSVs or Panda data frames or a JSON, and or even creating a Jira ticket. These tools are inbuilt, and we can of course create our custom tools and do whatever we want. But these common tools being inbuilt makes it very convenient. Now, just as a fun experiment, what if I ask the LLM directly the first question? The LLM is not using the tool. This is directly talking to the model. So it tells me that that it does not have access to real-time information, and as per its last update, it was 1974, which makes him 46 years old instead of 48. The reason is the LLM model was trained till 2021, so it still thinks that time.now is 2021. Now there's another type of agent called conversation react. So think of it as a modified and enhanced version of zero shot agent. So the zero shot agent works well, but it does not have memory. So if I ask a question, who is the Prime Minister of India, to the agent, it will answer it using Google search tool. Now, if I ask a follow-up question, what is his age? The agent will not be able to answer because it does not know who is his. It does not have a context of the previous conversation. So we have a conversational React agent which has memory attached to it. So it works just as a zero shot agent, but with an added memory. So let's go our code example. We are creating an LLM instance. We are loading an LLM math tool. We are now creating something called conversational buffer memory. We are passing a memory key. We'll talk about it a bit later. And then we are initializing the agent. The agent type is conversation React description, and we are passing the memory also. So I am asking two back-to-back questions. What is 4 raised to the power 3? Can you subtract 50 from the above result? Now, if I see the output, how it works is for the first query, the agent thinks that it needs to use a tool, and the tool's name is calculator, which is nothing but LLM math. Then it knows the input is 4 to the power 3, and then it gives an answer. So it's sure that now the answer for 4 to the power 3 is 64. Then it again, I ask a question, can you subtract 50 from it? So it thinks, does it need to use a tool? Yes. And we can see that it's now doing a 64 minus 50. It knows that 64 was the answer for the previous query, and it's able to give the answer as 14. So this makes it very powerful for conversational applications. Now we'll briefly talk about how the agent knows which tool to use. So think of it as agent. When we instantiate an agent with tools, we pass the description of each tool in English to the agent. So for LLM math, it's, let me try to search for what is the prompt for LLM math. So for LLM math, the description is useful for when you need to answer questions about math. Okay, this is Langchain's code. This is not my code. Now, similarly for other tools, we will be passing description for them to the LLM. So now, whenever an agent gets a query, it passes the query along with each tool's name and description to the LLM and asks it, hey, this is a user's query. You have access to these set of tools. Now, can you tell me which tool should I use, if any at all, to resolve this particular query? So the LLM now knows what are the tools which are there to be used along with what is the query. So LLM is a brain which decides that, okay, for this particular query, let's say in this case, 4 raised to the power 3, yes, a tool needs to be used. So then the first call, LLM will tell agent that you need to use a tool. The name of the tool is calculator, and it figured it out on the basis of the description of the tool. It also tells that for this particular tool, you need to pass it 4 to the power 3. So LLM basically understood that what is the query and then what needs to be passed to the tool. Now agent at this point, it gets the response from the LLM and it blindly executes the tool with the input passed by the LLM. So it goes to the math tool and it passes 4 to the power 3. The math tool responds with 64. So just remember, the tool actually runs on my computer. It does not run on LLM send. 64. Now it passes the entire conversation, the list of tools, the user's query, along with this particular observation, basically the response of the previous tool's execution to the LLM. And it asks it, hey, these are the set of values which I have. Do you think I need to use another tool? Or is this answering user's output, user's query? So at this stage, the LLM tells that, do I need to use a tool? No. It tells the agent, no, do not use a tool. The answer which you have is the correct answer. So I get it. It's a bit complicated, but this is what makes agents very powerful. Each tool can have their independent description, and we can load an agent with hundreds of tools and let the LLM decide, depending on the use case, which particular tool to use. So now we'll quickly talk about memory. So there are multiple types of memory in Langchain. One is conversation buffer memory. So what this does is it keeps a track of the entire chat history of the user, as well as the response from LLM, and it passes the entire history to LLM for any future query. So this is how the LLM is able to use the past history to get the context. The problem with this is that very quickly the amount of things we are passing to the LLM, the history, basically, it very quickly gets very huge. And each LLM has a particular text limit, or the maximum amount of tokens, or in a way text characters, which they can get as an input. So this approach is not suitable for large applications. We have something called conversation summary memory. Now what this does is it, instead of passing the entire history in the format, in the actual format, what this does is it summarizes the history and then just passes a summary in a few lines as context to the LLM. So this ensures that the context is maintained, and at the same time the size of the entire history is not increased significantly. There is of course there are disadvantages to this, that some context is lost in the summarization. Then we have conversation buffer window memory. It's just like conversation buffer memory, but we can specify the last key conversations which we need to pass as context to the LLM. Now another thing which we won't cover in this video is called indexing slash embeddings. Langchain basically provides very convenient interface to talk to vector databases. And using this concept, we can augment our LLM's brains. So as I mentioned, LLMs are trained only till a certain cutoff time. Anything after that, they do not know. Any private information, let's say I want to talk, I want to ask questions on a private, confidential PDF, the agent, the LLM does not know about it. So it's not possible for me to train my model over my own personal data, because I do not have the means. Plus, it's just too expensive and impractical to create a model for custom data. So what Langchain lets me do is I can pass some custom information to the LLM and tell it that, hey, use your own brain, but make sure that the answer which you are giving, it is from this particular information I'm passing you. So for an example, I can create an application using vector chain and LLM, which takes a user's PDF as an input, and then user will be able to ask questions on the PDF and the LLM will answer questions from the PDF itself. So this makes it very useful for a lot of applications, especially where private confidential data is involved.